Prasanna, any doubt or it's clear? Vaishnavi, it's clear?
Yes, sir.
Okay. If it is clear, then it's fine. Priyanka, for you, it's clear? So today we are going to study RC network. It's a very important topic. RC network. Then yeah. So I told you about the P average. P average is what? VRMS into IRMS into cos theta. Okay. For RL network or any we derived P average value. We got VRMS into IRMS to cos theta. Okay. So write the next heading, guys. See, if you have not understood the previous topic, so the same concept is coming. You will be able to understood again. Series. So please focus. Series RC circuit. Okay. So series RC means resistance and capacitance.
Capacity.
Yeah. So you have a network like this and capacitance. Okay. In this you will have AC voltage. So V of t voltage applied, I of t current will flow. Okay. This is your R, this is your C. It's positive, negative because current is moving like this. Okay. So some potential will develop. We assume this as a VR in a phasor form I am taking, and positive, negative we see in the phasor form I am taking. So what is the overall combinations of capital means this? If you'll apply the KVL, you will get V phasor is equals to VR plus VC. Right? This potential is the combinations of this potential plus this potential. Okay. V can be written as I phasor into overall impedance. Impedance is, our impedance in this circuit is R plus or minus, we can write J by omega C. Okay. So we already know XC is nothing but minus J by omega C. So the combinations of impedance will be resistor here and capacitance here, so it can be written like this. So that's why I phasor into Z, and VR will be whatever the current is going, I phasor current is going multiplied with R. This phasor means it have some directions. Okay, that's it. And your VC will be what? I phasor into what is the capacitance value? XC. We can take at minus J XC. You can take. You can take like this also. Here then XC belongs to 1 by omega C because we consider minus sign. That's why. So you can write like this also. I phasor Z is equals to I phasor R minus I phasor, this is the phasor representation, I phasor into, and this J is coming by omega C. Okay, this part is clear? If this part is clear, then you guys just tell me. Let us suppose, I will tell you means we know V is equals to L di by dt, I of t is equals to C dV of t by dt. Okay, if our I of t current was coming, I am sine, let me take like this. If our V of t current, V of t voltage was coming, Vm sine omega t, then current across capacitor will be I of t current we derived earlier itself, Im sine omega t, Im sine omega t plus or minus
Plus
plus 90 degree,
90 degree.
plus 90 degree. Okay. Okay. So if means okay, so and what will be the, this is your current. Okay, you got it. Means in this particular circuit we are having a current of Im sine omega t plus 90 degree. Okay, if you write this in the phasor form, it will be V at an angle 0 degree.
0.
And if you write this in the phasor form, what will be this? I vector, or let me write, wait. If you write in this form of polar form, I told you that this will come RMS, VRMS at an angle
0
0 degree. And this will come as a IRMS
IRMS at the angle of 90 degree.
at an angle of 90 degree. Yes. So these things you are getting. Okay. Now you are knowing particularly that IRMS at an angle 90 degree current is flowing. Okay, and this you have this potential means VRMS is voltage across this, VRMS at an angle 0 degree. Okay, right? Or any doubt? If you have any doubt, you can ask. So I'd consider the VRMS. Wait. Okay. So what I told means what I am telling, this I am considering this V of t is not belonging to, let me tell you this thing, this V of t is not belonging to this, means I am just telling about you, I am taking the capacitor voltage as a Vc of t. Let me write like this, Vc of t. Okay, this is not your V of t. So Vc RMS, this particular is Vc RMS. This is not V of t. I'm considering that our Vc of voltage is like this. Okay, or means if you guys will confused, means like okay, I will tell you in another way. No problem. See, so earlier we already discussed that thing. This is your capacitor. You are considering that this is Vc and this particular is VR. Current I is coming. This is your V of t. What will be Vc of t? Vc of t 1 by c integrations of I of t into dt, right? Remember or forget? Or means if you don't remember like this, Ic of t is equals to c dv by dt. If you solve this, what you will get? V is 1 by c Ic of t into dt. This size is dv. Integrate both sides, it will become v c of t, and it will be 1 by c integrations of Ic of t to dt. Prasanna, you understood this part?
Yeah.
Okay. So we can, means if you want to represent these particular things in the form of resistance, how can you represent? Minus j by omega c. You understood this part from the earlier derivations? We know that the capacitor can be equated as a minus j by omega c. You all guys, I think all guys remember this thing.
Yeah.
Okay, if you all guys remember, and suppose I of t current is coming from here. Okay, some I of t current is coming from here. That is I am just assuming it is a I at an angle theta degree. Okay, this theta degree, this is your v of t. So can anyone tell me, means what will be the voltage across this v of r? I at an angle theta into r. And what will be the potential across positive negative vc? Vc will be I at an angle theta into minus j by omega c. Am I correct, Prasanna? We can write like this. So
Yeah.
this resistor is not having any angle, so VR of resistor will be I into R at an angle theta only. Okay, but it minus j means what? Minus j means minus 90 degree.
90.
Minus 90, because minus
Yeah,
sign
yeah,
is there.
ma'am.
So Vc will come how much? I upon omega c theta minus 90 degree. Correct? This thing you got it? This angle, if you are not getting, just tell me. This minus j means Vc I at an angle theta is written into 1 by omega c, and minus j can be written like 1 at an angle minus 90 degree. It is also having angle, this is theta, and it is also having angle. So Vc can be completely written as I upon omega c at an angle theta minus 90 degree. Correct? Prasanna, understood how it came, or still having any doubt?
It's clear.
It's clear. Then we assume what? Our current which is flowing in
I of t.
I of t is equals to I at an angle theta degree. Okay, so suppose if you want to make a reference, means we are taking this as a reference. Okay, so from reference, where will be the current will lead or lag? Current will
With respect to reference.
with respect to reference, it will lead by 90 degree theta degree. Correct? With respect to reference is 0, and this is theta, so it will be from 0 to theta degree. Your current will be, this is I. What about Vc? I am asking about the capacitor voltage. It's having some magnitude. I am taking this as a Vc dash. So it is theta minus 90 degree. Theta minus 90 degree. So suppose this theta, and means we have theta, so some theta is there and some 90 degree is there. So if you will take like this, let me take, it is theta minus 90 degree. So suppose okay, suppose this angle is, if this particular angle is 90 degree, we are subtracting 90 degree now from this, theta minus 90 degree. So okay, let it be like this. So some angle is there, some means with reference it is theta minus 90 degree. Suppose it's coming like this, I'm just taking randomly, and this particular angle will be from reference, it will be theta minus
Theta minus 90 degree.
90 degree. This is your VC, right? What about VR? VR, your VR will be VR. VR is I R at an angle 0 theta degree only. So it will be
Respect to the reference.
with respect to the reference, it is a theta part. So this it will follow the theta angle. So it's going like this. So this your VR will be like this.
Mm.
Okay. Have you got this one? How we are getting? Or any doubt? Anyone having any doubt? Anyone having any doubt? Prasanna, any doubt?
It's clear.
It's clear. So see how we are getting, means reference to VR. See, these things needs a practice, so you have to do the practice by yourself. Means I am teaching and you have to revise again and again. Okay, and if you will miss the class, then you will not able to understand. So if you had not seen the previous topic, so I am just telling you guys, please go through it again and again. Okay, so see, this VR is coming and this VC is coming. What is overall VC? Overall V. Overall V is what we got the overall V. See, overall V is VR plus VC.
Plus VC.
Yeah. Okay. So okay, so overall V will be VR plus VC. So something like this we'll get. This is your V, capital V. Okay, guys, it's clear. And let me tell you, means another way. Section. Let's play with the vector. You have reference. Okay, you have a reference. So you want to draw for a capacitor. I'm not asking for you have to draw for a voltage or you have to draw for, I'm just telling you, you guys have to draw for a capacitor. So in a capacitor means like you have some, if you don't remember, just write I of t is equals to C dV, I of t is equal to C dV by dt. So I'm not telling you, just have to remember V of t is equals to Vm sine omega t. From there it will be clear that I of t will be some Im sine omega t plus 90 degree. Okay, from like this I will tell you. So suppose you want to draw a Vm. So Vm will be with reference. It will be here,
0 degrees.
right? This belong to capacitor voltage. Okay, so your capacitor voltage is this particular your capacitor voltage. And what about your current is capacitor current
90 degrees lead.
90 degree 90
Lead.
degree ahead,
Yeah. Anti-clockwise.
right? Anti-clockwise it's moving. So you are getting your IC current. Okay, this part is clear.
Yeah.
So can anyone tell me, means like if you got the IC current, you have, and you drawn for the VC parameter, that positive negative VC, and you the same current will flow now because it is in series. The same IC current will flow for R only. Prasanna, is this correct na? The same R current will flow na because it is series. Am I correct?
Yeah.
So
Because
see,
they are
yeah,
connected in
because they
series,
are
so
connected
the
in
same
series.
current will be flow.
Series. So what is the potential across the VR potential? VR will be your IC into R.
AC into R.
So what is the IC value? Im sine omega t plus 90 degree
90 degrees
into R.
into R.
So IMR sine omega t plus 90 degree. Suppose this as a VR dash. VR dash sine
At
omega t plus 90 degree. So where will be VR dash will be 90 degree with reference, it will be 90 degree ahead. So it is 90 degree ahead. So it will be in the same line of a IC, and we know that resistor will always follow the current path. So where will be the current, there will be the voltage of that resistor. Okay, so it will neither lead nor lag with respect to their current. So with respect to their current, it will be present on that line only, that vector only. So this is your, I'm taking some high point because it will be greater than IC because it is multiplied with R, and I am assuming R is greater than 1. So you got the value of VR also, VR dash also. This is your, means particularly this VR, this representing this particular VR. So you got the value of VR also. So now you have a VR and VC. VR and VC. So what will be the overall V? V is nothing but VR plus VC. So you just have to join them. This will be V. And this you have to take the angle theta. Right? So what will be the power factor? Cos theta. Cos theta is equal to base by hypotenuse. So cos theta, which is base here? Base is this VC.
VC by V.
And which is your hypotenuse? That is your V.
V.
So cos theta is equals to VC by V. So can anyone tell me what is the value of a VC? I into 1 by omega c. I am taking the magnitude only. Okay. So VC will be, this current is flowing, I current is flowing. So this I is multiplied with 1 by omega c. I am taking about the magnitude only. So for cos theta and all, you have to consider only magnitude. So this VC will be I upon omega c. And what will be the capital V? V is equals to I into Z. Right? R plus j omega c. So I am taking the magnitude part only. So that's why I am considering only Z. So I into Z. So this will cancel out. The cos theta value is also coming 1 omega c into z. Or you can write like this also, 1 by omega c is xc, cos theta is also can be written as xc by z. This part is clear, Prasanna? Or still having any doubt?
We are writing 1 by omega c as x, right?
See, Prasanna, what I am telling, you having a, you understood this one, how bc by v is came?
Yeah, I understand that.
So what I am telling, vc is what? Vc is ic into ic, means you have a resistor, you have a capacitor. This capacitor have a means value minus j by omega c. This is r. This particular is vc, and this I current is flowing. We are taking ic only, so just suppose this is a I current only. Okay. I and ic both are same only. Okay. What I am trying to saying, you are not getting, or you are getting, means this I is flowing in this particular your IC, because it is in series. IC all are same. So what is VC? VC is what? The product of I into R is VC. So this is your, suppose this is kind of a R only, register only. So you are getting VC is what? Minus J by omega C, right, into I. If you will take the magnitude part, what will come? This J will take the mod part, what will come? Only I by omega
I by omega c.
Okay. And overall V is this one, positive, negative, this V. This is the combination of R
And c.
R minus J by omega C into I. This is your capital V. This term is known as Z. Okay, impedance of R and C. So Z is nothing but R minus J by omega C. So what I have written, VC can be written as I upon omega C, and your Z can be written as I into Z. Right? So this is getting cancelled out. So cos theta value for RC circuit is coming like what? Cos theta is coming like 1 upon omega c into z.
Omega c z.
Okay. If this is clear, then do this one also. This part is clear, then it's fine. So see, you understood that Z is equals to R minus J by omega C. Everyone understood this part? Your impedance is R minus J by omega C. If you write in the form of an angle, so suppose the mod value of a Z will be what? The mod value of a Z will be root under R square
plus
1 by
1 by
omega c the whole square. And I'm supposing I'm taking angle, means the angle of this is I'm taking like theta. Yeah, tan inverse omega c by r. That is correct. But I'm assuming that it has a theta only. Okay. For right now. What is the, and if we can write like this, so suppose Z mod value at an angle theta. What is R? R is nothing but R at an angle 0 degree. And what is minus J by omega c, meaning mod value will be omega c
minus 90
minus 90 degree. So plus 1 by omega c at an angle minus 90 degree. You understood this one? So we have a reference. Reference is 0. So if you want to draw the R, where will be R?
with respect to the reference.
Yeah, with respect to the reference. So this will be here only. Your R will be here only. Correct?
Yeah.
At an angle 0 degree. So with reference it will not move. It will stick on that reference point. And what about your 1 by omega c? This is minus 90 degree. Means R at an angle 0 degree plus 1 by omega c is xc at an angle minus 90 degree. So what about minus 90 degree value? It will move, lag or lead with respect to Z.
Lag.
Lag anti-clockwise. It will lag by
90 degrees.
90 degree. So this is your XC. This particular is 90 degree. And what was the meaning of Z? Z is the combination of R and
R X.
C. So let me take. This is theta. Okay, with respect to R, you have to assume theta in this RC network and all. So, can anyone tell me what is cos theta? If you are assuming from here, what you will get cos theta? B by base by hypotenuse. Oh, sorry, I did mistake. This is your R. This particular R. No. Theta will be here only. So, what will be the cos theta value? Base by
Hypotenuse.
base by hypotenuse. So, what is base? This particular is base because theta is this. So XC upon, or let me check one thing. Oh, I did some mistake. Wait, let me check. Just wait. The thing is that, yeah, if you will assume theta, then XC will become, you guys are correct only, and if you will take theta here, then cos theta will be
R by Z.
R by Z. So we got here something means we did some mistake here. Let me correct it. Because we'll get R by Z here also. Okay. Yeah. That's why. Sorry guys, means I just see, wherever the R part will come now, that part will be your theta. Okay, so here R, your resistance part, where is coming? Your resistance part is coming in that na, in a voltage parameter, resistance is coming here na, so theta will be here, right? So theta will be here. So I apologize for that, did mistake here. So means wherever the R part will come, you have to assume theta that side only. Okay, so this was your IC and this was, you are getting the VR resistance. So now what will be the cos theta? Cos theta will be VR by V, and VR is nothing but I into R, and V is nothing but I into Z. So you will get cos theta is R by Z. Okay, it won't be VC by V. So if you had written, so please correct it, because I had assumed theta here. Okay, you have to assume the theta particles, theta things with respect to R only. Prasanna, it's clear? Prasanna, or you want me to explain more once again, or it's clear? Prasanna, it's clear? Vaishnavi, for you it's clear? Priyanka, it's clear? Vaishnavi, just say.
Clear, sir.
Okay.
Yes,
Okay.
yes, yes.
Okay. So means you understood, means you have to assume theta where the register part is coming in your vector. Okay. Always remember this part. So what I am saying, guys, and you have to check, means you have to say whether this things is lagging or leading load. Lagging or particularly leading. So lagging and leading, particularly it's happening with respect to something. Okay, if anyone will ask you about you know you have you get to know this particular thing with respect to, if anyone will ask you in a impedance, what will happen with a capacitor, whether it lag or lead, what you will say? In impedance RC network, capacitor lags or lead? Resistor lags or lead resistor? What what you guys will say, whether it's lags or lead? Capacitor. Z is equals to R minus J by omega C. So from this we drawn this diagram. Your R is this and your XC is this. So this represent the capacitor value. So capacitor is lagging or leading? It is
Lagging.
yeah, it's
Lagging.
lagging. It's lagging. It's lagging. Lagging for Z. But for inductor, what will happen? R plus J omega C, J omega L is there. So if you will draw the phasor diagram, you will get R and J omega L here, and this is Z. So it is leading for inductor. Leading for what? Means your inductor will lead the resistor. Inductor will lead the resistor in impedance triangle. Okay, so these things. But with respect to current, now with respect to current, if we'll go for a current, opposite thing will happen. Okay, so in this, in a current parameter, what will happen? Current lags the voltage, and here current leads the voltage. Okay, now you guys will say how it is going to happen. Means, like, we have net Z is equals to R plus, for I'm saying for a capacitor, R minus J by omega C, correct? What is the formula of this is for capacitor, and you are assuming this as a Z, and here I current is coming. Suppose you have taken I at an angle 0 degree only, and this particular your voltage. So V is equals to I 0 degree into Z, right? Right now, Prasanna? V is equals to I into Z. Am I correct? So,
Yeah.
so if you will know, if you will get to know, if you will get to know, means these things, I at an angle 0 degree, and you have the value of a Z is equals to R minus J by omega C. What is the magnitude of this? If you will solve this, root under R square plus 1 by omega C the whole square. So you are getting V into I into some, this particular as I am taking as a mod Z, and here angle 0 degree is there, and the angle of this particular Z will be how much? Tan inverse B by A. So B is minus 1 by omega C.
1 by omega C by R.
So tan inverse minus 1 by
Minus
omega RC.
omega.
Am I correct? This part is clear. So see, this is this is your A part, this is your minus A part, this is your B part, and this is your minus B part. So in which quadrant the angle will lie? We have a negative B. So negative B is coming here. We have positive A. Positive A is coming here. So it will the angle will come in
Fourth.
fourth quadrant. Okay. Right. So it is like the angle will be 0 degree, 0 to 90 degree, 90 to 180 degree, 180 to 270 degree. So angle will be between 270 to
360.
270 to 360 degree. So put any value like tan 270 degree in your calculator, or tan 222 or tan 280, what you are getting. First you have to convert, means don't keep it in the radian form. Okay. Tan 282 value, what you guys are getting?
Minus 4.7.
Minus. So the value, whatever the value will come na, it will be in a minus. Okay, it will be in a minus. So I am assuming we are getting some minus 5 value, right? I am assuming some minus 5 value we are getting. Yeah, whatever the value you will put na, thus every value will come in negative. Okay, so the z will be, means like yeah, 0 into 1 at an angle minus 5. If you solve this, what you are getting? V into I of z at an angle minus 5. What is the meaning of this? For RC network, if you have a current I at an angle 0 degree, with reference, this is reference only, what is the voltage you are getting? Some minus. So some negative, means negative represent the lagging part. So that's why we are going particularly down. So phi is coming. So which is leading and which is lagging? From this, what we conclude? In a RC network, current leads by some particular angle, by angle phi, and voltage lags by angle phi. Understood, guys? Or anyone having any problem? Vaishnavi, understood? Priyanka, understood? Prasanna?
Clear, sir.
Clear. If it is clear, then suppose we have R network, we have L network. Okay, I am taking I at an angle 0 degree. I am assuming just. Okay, this is your positive, negative, V, overall V. So, and what about Z? Z will be R plus j omega L. What about V? V is equals to I into Z. What is the magnitude and polar form? Z is equals to mod of Z is equals to root under R square plus omega square L square. And angle of Z will be tan inverse omega L by R. Now suppose omega L is B and this is A. So it is A, it is minus A, it is minus B, it is B. So the angle will be in first quadrant only. Okay, whatever the value you will put, tan inverse means that the angle will be in the first quadrant only. So whatever the first quadrant belongs to 0 to 90 degrees. So whatever angle you will put, you will substitute, you will get the positive value only. Okay, so this represent, this meaning what? This meaning phi. So this is nothing but I was having some angle 0 degree, I am assuming 0 degree, and your mod Z with angle some positive phi. So V was coming as a I mod Z at an angle phi. So this means what? if you are drawing with reference, and if you are drawing the current I current, so I current will be here only, I. What about V? V will have some phi angle. So in a inductor, in a RL network, which is leading and which is lagging? Voltage is leading. Voltage is leading what? Current by an angle phi. Or we can also say that current lags by an angle phi. We generally talk about the current, not about the voltage. So you always have to remember about the current. For inductor load, whether it will be connected with R, so you have to say that lagging power factor will come. And if you are going for a capacitor load that is connected with R, you have to say that leading power factor. Okay, it is universal, means like universally we say power factor for current with respect to what? With respect to voltage. So for inductor the power factor is lagging, and for capacitor the power factor is leading. Everyone, it's clear? Prasanna, it's clear?
Yeah.
If not, you can ask. If anywhere you are facing any difficulties, you can ask. Sharon, for you it's clear? Vaishnavi, if you guys are still facing any difficulties, you can ask.
No, sir, clear.
Okay, fine. If it is clear, then so guys, here also reactive power and real power will come. Okay, real and reactive power will come in this. Okay, so suppose we are talking about the RC network. So if you are taking Vm sine omega t, and so in a RC network current is lagging or leading? Anyone can say, in a RC network what will happen? Current will lag or lead? Current will lag. I only told you now, in a RC network current will lead by phi. Just only I told you guys.
Okay, that is a wrong.
Just only.
Leads, sir.
Yeah, it will leads. So in a RC network current will leads. So I am putting Im sine omega t plus phi. It's leading by some phi. Okay, that's why I assume here as a plus phi. Okay, now you have a voltage and you have a current parameter. What about the power? Power is what? V of t is
V into I.
V of t into I
of t.
I of t. What about the average power? Average power what we are taking? P is equals to 1 by time period integration of 0 to t V of t into I of t into dt. So this is the formula for average power. So if you will solve 1 by t 0 to t, V of t is Vm sine omega t into Im sine omega t plus phi. So if you solve this, what you will get? Vm into Im by t. This is 0 to t. And this is, I am taking 2 ups and 2 down and up multiplications. 2 sine omega t into sine omega t plus phi. So what is the formula for sine A sine B? To sine A sine B, to sine A sine B, what is the formula? Cos A minus B minus cos A plus B. So if you substitute this, what you will get? Cos A minus B, omega t minus phi, omega t minus phi, minus cos, all will be plus 2 omega t plus phi. So from here what you are getting, Vm Im by 2t 0 to t, this is getting cancel out. So you are getting cos of minus phi. Okay, cos of minus phi, and this particular is minus cos 2 omega t plus phi. So if you will take this as a Vm into Im by 2t splitting 0 to t, cos of minus phi is cos phi only, cos of minus phi is cos phi only, cos minus theta is equals to cos theta. So I am writing cos phi into dt minus 0 to t cos 2 omega t plus phi into dt. So this is the trigonometric function. So average of the trigonometric function is 0 only. It having a t function, that's why. But this is a constant value. Cos phi is a constant value, so this won't be a 0. If you solve this, you will get Vm into Im by 2t. This will be your cos phi, and this will come 1, t will come. So this t will get cancelled out. So Vm into Im by 2 cos phi, that is nothing but Vm by root 2 into Im by root 2 into cos phi, that is nothing but Vrms into Irms into cos phi. So this is your P average value. Got it, guys? This part is clear, guys? Okay. If this is clear, then say me. So suppose you have R network and you have a C network. So I'm supposing that some angle I angle theta is coming. You can take, means I'm just supposing I angle at an angle theta, and this is R. This is minus j by omega c. So what will be the power across this particular load? Power is what? I square into R. Remember, guys, power is I square into R. Or you don't remember this thing? Power is equals to V into I, na? V can be written as I into R, na? So you will get I square into R power, right? Or if you don't want to go in this way, we have another option. you have another option. So in a, that is your, I'm taking this, I represent IRMS, and this is your VRMS. So I am taking means in a inductor, in a RC network, your voltage will lag and current will lead. So I am taking this as a 0 degree. So suppose this is 0 voltage, the current will lead by some particular theta angle. I took like this, we at an angle theta. So V into I at an angle theta, this is 0, that's why it will be theta only. It will give you overall power, that is called as apparent power. Okay. So guys, if you'll solve this, S is equals to V into I at an angle theta. I at an angle theta. Okay guys, so if you will solve this, what you will get? V into I, this one at an angle theta can be written as cos theta plus j sin theta, and this is RMS value, VRMS. This is your also RMS value because we have written in this form. So always remember this part. So VRMS into IRMS into, we can break this form in this form, theta form in cos theta plus j sin theta form. So it will come cos theta plus j sin theta. So S is coming like what? V into IRMS, VRMS into IRMS cos theta plus j VRMS into IRMS sin theta. So this is your average power. You can say it as a real power. Average power, real power. This is your reactive power. And this average power, real power, not reactive power. This is not reactive power. And this is your reactive power. Anyone having any doubt up to this? Prasanna, any doubt up to this?
Nothing.
Got it? How we got this thing?
Yeah.
Okay, then it's fine. If means like if you want to find the concept, means what is real power, what is apparent power, just directly take the magnitude. You can also do, if anyone is asking what is the real power and what is the reactive power, take the magnitude in a RMS form. Take the RMS value, square it, multiplied with this. So this will be real power. And if anyone is asking about reactive power, take the RMS of this and take the magnitude of this and do the same thing, I square into 1 upon omega c. You will get the reactive power in this case. Okay guys. Okay. Okay, like we can do also like this now. V divided by R minus J upon omega C. Okay, so this will give you, and suppose we need to find the value of current in this. So this current will be what? This current will be V divided by Z. Okay, so V divided by Z we are getting. I is equals to V divided by Z. So suppose if you want to take in the form of a phasor, so V at an angle 0 degree, this Z we can write as a mod Z at an angle minus theta degree. Plus means whatever the value is coming, this theta, whatever the theta is coming, I'm just considering as a theta. So if you will take I is equals to V by mod Z, so whatever the angle means, whatever the angle was come, it will go upside as a minus theta. Okay, minus theta, it's going upside as a minus theta. So this particular value is your I value. I is equals to V divided by mod Z at an angle minus theta. Whatever the angle will be this, so if it will go upside, it will minus will come. So you have I, you have a V, so S is equals to what? V into actually remember this point means for finding the value of S now, this is very much important. You just note like this. I'm just telling you. S is equals to V into I conjugate. We use this. Although you can apply these things, it's okay. It's pretty good. But for examinations, you have to apply S is equals to V into I conjugate. Why so? Because these angle sign is getting reversed while you are putting it in a up. Okay. So see, for means like I am giving you a crux, like this is your RL network, this is your RC network. Okay, so in a RL network what will happen, you have R L and you have R C. Okay, in a RL network we have seen that equivalent Z like Z like this means you having a, if resistor is like this, so inductor will lead, your XL will lead. This is Z. One diagram was coming like this. For RC, how the representation will be? If R is this, your XC will lag. So Z will come here. And this particular is 90 degree. This is R, this is XC, this is XL, this is R. So it is for RC network. So in this what we had seen, your inductor is leading the resistance by 90 degree and here the capacitor is lagging the resistance by 90 degree. So write it down for power. For power the diagram will follow the diagram will follow, same diagram will follow. Wherever the R will come, you have to write P. Wherever XL is come, you have to write QL. This P represent real power and this QL represent reactive power. This is your apparent power. S is equals to apparent power. And theta will be respect to this. Here also you have to follow the same as the register diagram. So R is nothing but R will be R means like P. R will become P and XC will become QC and Z will become S and theta will be this. Okay, this is your reactive power. So how can you represent this in the phasor form? S is equals to P minus J QC. And how you will represent this in the phasor form? S is equals to P plus JQL. Okay, this is very much important. Very much. So the last things is very much important. You need to know these things. So from here and relations between current and voltage. So in a RL network, if you have a voltage parameter V, this, so current will lag at an angle, some particular angle, some theta angle I am taking, and in this current will lead some theta angle for RC network. So that's why this is we say that for power factor, inductor is having lagging power factor, and for capacitor we say it has a leading power factor, because we always consider current with respect to voltage. So that's why current is lagging, that's why it is known as lagging power factor. Current is leading, that's why leading what? Leading voltage, that's why it's known as leading power factor. What is power factor in power factor in your RC network? That is cos theta. Cos theta you can substitute from any triangle B by H. So this is your theta, so you will get base R by Z. R by Z. Here also cos theta will be R by Z. Okay, and you can take cos theta is this P by S also, real power by apparent power. Here also cos theta will be P by S also, real power base by hypotenuse, so real power by apparent power. Here for a lagging load, yeah. And one important thing, just remember this formula, S is equals to V into I conjugate. Okay, this is very much important. So you have to apply this for finding the apparent power. So suppose means like you are having a current, means how we are getting like this means see, you are having a voltage V at an angle 0 degree and if you and for RC network I am saying, and you have a current I is equals to I at an angle phi. Okay, so if you will not conjugate, what you will get? V into I at an angle cos angle phi. If you will not conjugate this thing, and the result will be Vi cos phi plus J sin phi. So if you are not conjugating now, you are getting, and this is RC network, you are getting means like this Vi cos phi is representing P, and plus this all Vi multiplies there, J Vi sin phi is representing J Q. So this part is not for capacitor, this was applicable for inductor. Okay, in inductor we are getting like this, see, S is equals to P plus JQL, and we are doing for a capacitor, see, RC network we have assumed I at an angle phi degree, and we are getting P plus JQ. See, that's why we need to do conjugate. So we are doing the conjugate. If you do the conjugate, automatically minus sign will come, and you will get here minus. Now it's true, you are getting P minus JQ. So finding the apparent power, you just have to do V into I conjugate. Guys, up to here it is clear, or anyone needs any explanation more? Prasanna, you understood?
Yeah.
Okay, then it's fine. Vaishnavi, for you it's clear? Priyanka, for you?
Yes, sir.
Okay. While solving the problem, we'll get more about this. Don't worry if you are still facing problem. Okay, so series RC we did it. Now the turns of a very important part, that is series RLC network. This is very much important. So guys, we are solving for RLC network. You don't need to remember any formula, just understand the concept for network theory. So this is particularly resistance R, this particular your inductor L, and this is your capacitor C. Suppose we are having I of t, and this is your V of t, it's positive negative VR, this is your positive negative VL, your positive negative BC. So in this whole we are getting, we are it's following I of t current, correct? I of t current. So overall V phasor is the combinations of VR plus VL plus VC. VR plus VL plus VC. If you apply the KVL, you will get VR plus VL plus VC. So guys, R, I am representing this as a j omega L, and I am taking this as a minus j by omega c. And our current, suppose I current is I at an angle 0 degree. So what will be the VR value? I into R at an angle 0 degree. What will the value of a VL? I into j omega L, that is nothing but I omega L at an angle 90 degree. What is the value of a VC? VC will be I into 1 by omega C at an angle minus 90 degree, because minus j omega C will come. So now draw the phasor, get the result. This is your reference. What will be the VR? VR is I into R, means first draw I. I is at an angle 0 degree only. So this is following your I. What about VR? VR is also at the same angle. Okay. So VR is this particular is your VR. What about VL? VL will lead by 90 degree. So this you are getting your VL. What about VC? VC will, guys, VC will lag by 90 degree. Lag by 90 degree. Okay. So the thing is happening like this. So, now see this phasor, one phasor is going in a this way and one phasor is going in a this way. What is the meaning? The meaning of this is, if your VL is greater than VC, the net phasor will be if VL minus VC. Okay, if VL is greater than VC. But if VC is greater than VL, this will true for VL is greater than VC. If VC is greater than VL, then the phasor will come down. Net phasor will come down. You will get VC minus VL. Okay. So if this is the result, then you are getting overall voltage between this. And if this is the result, if VC is greater than VL, you will get the overall result this. So if this case is happening, then it's behaving like an inductive load. Inductive load. And if this case is happening, it's behaving like a capacitive load. Okay, if VC parameter is greater than VL, then it's behaving like a capacitive load, and if VL parameter is greater than VC, it's behaving like an inductive load. So if it is an inductive load, the power factor will be lagging. If it is a capacitive load, the power factor will be leading. Okay. So same is true for, means see. Now you have this particular RLC. So this overall is your Z. This is R, this is L, this is C. This is positive, negative, V. If you write in the form of resistance, how it will come? R plus j omega L minus j by omega C. This is your Z. So suppose Z is with, or you can take R plus j common omega L minus 1 by omega C. Right? So at an angle theta I am taking. So suppose this is your crux. So what you are getting mod Z value root under R square plus omega L minus 1 by omega C the whole square. What about the angle? Tan inverse omega L minus 1 by omega C divided by R. So guys, if omega L is greater than 1 by omega C, then that's mean it's a positive. If omega L is lesser than 1 by omega C, that means it is negative. If it is a positive, then it's the angle is coming in a first quadrant. If omega L is lesser than 1 by omega C, that means the angle is coming in a fourth quadrant. So it's depend, means by RLC network we can control the network as an inductive network or capacitor network by changing the value of an inductor and by changing the value of a capacitor. Right? So we have a diagram like this. Suppose, yeah, suppose we want to make, we got this diagram right now, like VR diagram. So VR was this VR diagram. So suppose you are taking your this is your VR. You are assuming your VL is greater than VC, so VL minus VC will come upper side. And this will give you net voltage V. Okay, this is VR, that's why the theta will come this. This will be the theta. Okay. And if your VC is greater than VL, then the result will be like this. It will come down. This is your VR. This will be the theta and this will be VC minus VL. Okay. For a Z, it will come like this. XL minus 1 by XL minus XC. XL is nothing but omega L and XC is nothing but 1 by omega C. We can write like this also. This is your R. This will be theta. What is the meaning? XL is greater than XC. If you are getting like this, if the circuit is this is, if you are getting XC minus XL, that means your XC is greater than XL. You are getting the circuit like this. Okay, this part is clear for everyone. So this is the RLC network. Guys, this part is clear to everyone, or still having any doubt? So for this is applicable, this cos theta is equals to R by Z. Remember this point. Cos theta is VR by V. Remember this point. And cos theta is also real power divided by apparent power. We already discussed how it's coming earlier. Guys, if anyone having any doubt, they can ask. Prasanna, any doubt? Priyanka, any doubt? Vaishnavi, any doubt?
Got it.
Clear? Got it? Concept is clear? Lagging, leading concept is clear? Okay. Okay, that's good if you clear this concept. Average value we discussed. Yeah, correct. So next topic we have to discuss that is our we completed the series network. Now we are moving for a parallel RLC network. This is another topic. So we'll study tomorrow this one. Parallel RLC circuit. Okay, for half an hour we'll discuss the previous questions, means for basics chapter questions. Okay, up to 14 question we discussed na Prasanna.
Yeah, up to 14 we have done.
So means for a series RLC the things is done, and like it's clear. You just go through it. The previous topics means like whatever the topics, and the recorded videos is with you guys only. Okay, so it's I'd already uploaded that things. So I will start the questions discussions. So up to 14 questions. So please open the PDF. I think I had already uploaded that PDF. So please guys open that PDF with you. So what is the 14th question? Let me stop this video.